Hi, Addy. Welcome to lesson number 86. This lesson, you are going to love this lesson because we go over the area of a circle, and that is going to be, I promise, on every test you ever take from now until the end of time. It's going to be on your ACT, on AP tests, on your SAT, all of those acronyms. They are going to have this on there for sure. And guess what? They're not going to give you the formula. So you're going to have that in your head and dripping off your tongue so that you can do these questions super easy, and you will be able to, and your friends are going to sit there for 5 minutes and try to remember the formula for the area of a circle, but you are going to know it. So here we go. Let's jump right in. Actually, the first thing we're going to do is I want you to do your facts practice, the math facts. So get that out. Make sure you have a pencil, and you have 5 minutes to do 30 fractions to reduce. And so I'm going to actually get out a timer. Let's see, where's my timer? Sorry about this. Okay, here, actually, okay, I can get this. Okay, let's stop that, reset it. Okay, I really can do this. Ready? And so can you. You have 5 minutes. On your mark, get set, go. All right, Addy, I'm gonna stop it right there. And let's go back to the lesson. Okay, good job doing those fractions that you needed to reduce. Okay, let's look at this comic. So this is a Far Side comic, and this doesn't have any words that go with it. It just is a picture that tells a story. So this is supposed to be a snake. It looks like he just finished eating. And this is like a baby's playpen. We used to have these in the old-fashioned days. I don't know if you've seen something like this anymore, but it looks like there's a little baby toy and a baby bottle, and I don't exactly see a baby unless you know where the baby is hiding. So this is kind of a sad, a little bit dark comic. I don't know if you think it's funny, but it looks like the snake got stuck in there for some reason. I think you can figure it out. Okay, let's jump into mental math. And this kitty is going to count along with our beat as we do this, okay? So for the first part of mental math, we are going to count up and down by twos between -10 and +10. Okay, so here we go. I've got a number line to help you if that does help you. So here we go. -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. And then let's go back down. 10, 8, 6, 4, 2, 0, -2, -4, -6, -8, -10. Okay, we did it to the beat of that kitty. All right, let's jump into the rest of mental math, and we're going to do 60 times 60. Let's see if you can do it, Addy. This is tricky. You know that 6 times 6 is 36. And how many zeros are there going to be? Okay, let's do the next one. It's 850 minus 170. Write your answer. That dog was swimming before they even put it in the water. I wonder if we could do that with Shadow in the pool. All right, let's do C. This kitty's going to give you a high five for doing C. Ready? $8.99 plus $4.99. That one is tricky. All right, D. What is 1/5 of $2.50? 1/5 of $2.50. I see the number 25 in here, and I know that that can be divided by 5, like 5 times 5 is 25. So probably that's going to be in your answer, huh? What about E? 0.08 times 100. So we're going to move that decimal 2 places. Which way is it going to go? Is it going to get bigger or smaller? That's a silly dog in that picture. Okay, F. Let's do 360 divided by 120. 360 over 120. Can you reduce this fraction? All right, what about G? You ready for this one? And we're going to see a very patient doggy while we're doing this. We're going to start with the number 6 times 6, and then subtract 6, divide by 2, subtract 1, divide by 2, multiply by 8, subtract 1, and divide by 5. What do you get? That kitty is lucky that that dog is so patient, huh? All right, Houston, we have a problem, and they need you, Addy, to figure this out. We are going to fill in the missing digits. And this is hard because they only give you one number, but you know there are 2 digits here, and there are only 2 digits in the answer. So we know that this can't be anything bigger than, I don't know, what would make this over 100? If you multiply this by 8 and it makes something 100 or more, then that's going to be too many digits for this. So anyway, that's a little clue. And then you're just gonna have to try it by trial and error, I think, and just like put some numbers in, because the other rule that it tells you is that no two digits in the problem may be alike. So there's gonna be no 8 in the answer or in this part. And you can't do like 11 times 8 because 1 and 1 are the same. And plus that would give you 88, and that's the same as 8. So it's gonna have to be something that is not repeated. So you could do maybe a 0, but then that would give you an answer that was a 0. So just go through, can't be 11, can't be, well, just try it. Just try it and see what you get for different answers, okay? All right, and while you do that, because you're definitely gonna have to pause it there and spend a little time on that, and I'm gonna jump into the new concept. And the new concept is all about circles. That's why I put that little lava lamp circle picture up there for you. And we're gonna talk about finding the area of a circle. So you have already learned how to do the area of a square, the area, which is the base times the height, right? The area of a rectangle is the base times the height. The area of a triangle is 1/2 the base times the height. And now we're gonna learn the area of a circle. Okay, so you're gonna know how to do the areas of all sorts of different things by the end of this. Okay, so first of all, they give you a picture in your handout that looks a little bit like this. So find that picture. And then it says, we can estimate the area of a circle by sort of drawing a circle on this grid. The background is a grid. And then count the number of square units that are inside the circle. So we're gonna focus on that. We're gonna count the number of square units. And it doesn't, so this is 1 unit. And this is 1 unit, and this is 1 square unit, okay? It doesn't tell you what the units are, like this could be a centimeter. I went a little too far. A centimeter, it could be an inch, it could be, maybe it's a humongous circle and it's actually like a foot or a yard or a meter, right? It doesn't tell you what the unit is, it just tells you that this is 1 unit. And if that is 1 unit, then this would also be a unit going up. And then that means that this would be 1 square unit if it's a perfect square, okay? So the circle is drawn on the grid, and the first question it asks is how many units is the radius of this circle? So what is the radius of a circle? It goes from the center to any point on the outside. And if it is a perfect circle, then that is the same as this, it's the same as this, it's the same as this. You can use all the spokes on the wheel, and the radius is the same no matter where you draw it from. But it is convenient to draw it from the center to this point on the circle because that's a perfect horizontal line, and it matches up perfectly with our grid system. So when it says how many units is the radius of a circle, we're just gonna count the units that it takes to get from the center to an edge. Ready? So we start here and we go 1 unit, 2 units, 3 units. That's why this is a convenient spot. It looks like this might be less than 3 units, but it's not because it's diagonal. And so this is also going to be 3 units. This is also 3 units. You can see that it's 3 units up and down. Whenever it's a perfect 90-degree angle, it's 3 units, but everywhere in between, it's also 3 units as well. So this is 1, 2, 3. So we can say the radius of the circle is 3 units. And then it says to estimate the area of the circle. Now it hasn't told us what is the formula yet. What is the formula? So it's gonna pretend that we don't know the formula. So even if you already know the formula for the area of the circle, which I know because I memorized it when I was your age, it's pi r squared. But I'm gonna pretend I don't know that for now. And what we're gonna do is we're gonna estimate the area of this circle by estimating how many square units it takes up, okay? So for example, this is, whoops, I made that way too fat. Let me try this. Okay, so let's count the square units. So this is 1 square unit. 1, 2, 3, 4 square units so far. 4 square units. But there's more, right? Because the circle is taking up more. So this is 5, this is 6, this is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 square units. Now, there are some more square units, but the whole square is not inside the circle. So I'm going to count some of them if most of the square is inside the circle. So far I have 16 square units. How about this one? 17, 18, 19, 20, 21, 22, and 23, and 24. So far, I have 24 squared units. So I'll say units squared. Okay. But that's not all. There's also these little half squares that are inside the circle. So now we're going to count all the half squares that are inside the circle, and if it's a half square, then I'm just going to put a dot in the circle. Okay, so ready? Let's do 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 half squares. So instead of counting a whole square, instead of 8, I'm going to divide that by 2, and that's about 4 more square units. So I'm going to add that to the 24. So 24 plus 4. And I can estimate that there are 28 squared units in the whole circle, because it was 24 full units squared plus 8 half units. Okay, so if we were to estimate the area of the circle, I would say it's 28 units squared. Okay, but if we want to find the exact area of a circle, that involves pi. It's not a pie like this delicious pie, it's the number pi. Okay, and remember that we estimate that to be 3.14, even though it's a number that has digits that go on forever. Okay, so we're going to look at another example. This example is also in your book. So this is what they say, and this is how you can sort of explain why the number pi is in there. So when we find the area of the circle, now this circle is not on a grid, but we can still estimate the area of this circle by sort of imagining that there is a square here, and like this is 1 square unit. And because they started the square right there in the center of the circle, this line is actually the radius of the circle, which is 10 millimeters. And also, this line is the radius of the circle, which is also 10 millimeters. So imagine that you kind of had like 4 squares that went like this, right? So if you know the area of 1 square, if you can figure that out, because you already know how to do the area of a square, right? The area of a square is the base times the height. So the area of this red square would be 10 millimeters times 10 millimeters, which is 100 squared millimeters. And how many squares does this circle take up? Well, it doesn't take up 4 because look, there's some extra space right here that we're not counting. So it's not quite 4 squares, but it's also not quite 3 squares. It's in between 3 squares and 4 squares. And turns out that the number of squares that it is in between 3 and 4, and it's actually 3.14 times the area of a square, which is the radius times the radius. And guess what? This is what gives you the area of a circle. It's as if there's a square, which is radius times radius, and it's 3.14 times the area of the square. So let's calculate that. So it would be 3.14. Pi doesn't have any units, so I'm going to leave it unitless because it's a ratio, but we'll learn about that another day. Times the area of this square, which is 10 times 10. So it's 100 millimeters squared. And the answer there is going to be 314, because you did mental math right here, moving that decimal, 314 millimeters squared. And that is the area of this circle. Cool, huh? So now we know that the formula for the area of a circle, which is area equals pi r squared. I want you to remember that for sure. There's going to be a thought cloud around this, but we're going to come back to it, okay? Let's do one more example. We're going to estimate, well, actually, we're going to calculate exactly the area of this circle. And it's the same for any circle, even the circle that this dog is walking right there, right? So the radius of a circle, they're telling you, is 3 centimeters. So I'm going to write that information down because it's important. I'm going to write it right here, 3 centimeters. And then it says, what is the area of the circle? Okay, so now we know the formula. What they tell you to do is they're like, okay, figure it out if you don't know that formula yet, but you can estimate the square, right? So if there were a square here, let me fix that line from there to there. Okay, the area of this square would be 3 centimeters across times 3 centimeters up. So the area of the square equals 3 centimeters times 3 centimeters, which is equal to 9 centimeters squared. But that's not the area of the circle. They want to know the area of the circle. So the area of a circle is 3.14 times the area of a square, which we already figured out was 9 centimeters squared. And then just either get out your calculator or calculate that out. Area is going to be equal to 3.14 times 9, which comes out to be 28.26 centimeters squared. Now, you don't have to think about it in terms of squares every single time because you're going to already know the area of a circle, which is 3.14 times the radius again, or 3.14 times the radius squared. Okay, so as long as you remember that formula, all they have to do is give you the radius, and then you can calculate the area of any circle. And remember, a circle means, it's not the same as an oval. A circle means that the distance from the center of the circle to any point along the circle is the same. That's what a circle is. So the area of any circle is pi times the area of a square built onto the radius of the circle, or area is pi r squared. You knew it, right? You knew it. All right, so this is the formula that you have to have stuck in your brain no matter what, because on every test, they're going to give you the radius of a circle and you're going to have to calculate the area. Now, this is how they're going to trick you. They will sometimes give you, instead of the radius, they will give you the diameter of the circle. And what you have to do is remember that the diameter is from one side of the circle to the other and it goes through the center. So the radius is going to be half of the diameter. So if they give you the diameter and they say it's like 10 centimeters, don't use that for this equation. Use 5 centimeters because that's going to be half the diameter, and stick a 5 in there. 5 times 5 is 25 times 3.14. You're going to figure it out that way. Okay, so that's how they're going to trick you, but you are not going to fall for that because you are super smart. Okay, let's stretch it out. That was a long lesson, but you got it. And then I'm going to let you go ahead and do your homework now, okay? Love you, Addy. Have a great day. Bye.